listen up. You saw in the video how this works. Let's look at our instructions. Everybody pull out your instructions. Number one, you will make a sedimentary rock with your starburst right now in a minute. Number two, to make this rock metamorphic, place it on the wax paper. There's a little piece of wax paper in there. You'll place it on the wax paper and blow dry it when you get home. And then after it starts to melt a little, you'll press it down like you did in the video. And that will make it metamorphic. Then to make the rock igneous, I have it that you put it in the microwave for 20 seconds on the wax paper. The first time I did this, I thought, oh, about a minute, okay? I put it on a microwave safe bowl. I didn't put any wax paper in there. And the rock, the starbursts were stuck to the bowl. It took 3 days for that to soften and get off. That's how hard it was. So you do not want to do that. 20 seconds is plenty. It will melt, and then you'll take it out of the microwave and let it harden, and it will be very, very hard. In fact, the wax paper will probably stick to it. You'll be able to pound on it. Now, if you don't have a microwave, you may have seen in the video how he did it. He did it where he double boiled it. So you put the starburst in a little piece of Tupperware, and you hold it over the steaming water. That's another way to melt it, okay? It's probably a better way to melt it, really, is doing a double boiler situation. But you don't have to. You can do it in the microwave. It's faster. So what I would like you to do right now is go ahead and take out your starburst. Did you get one? Or yes, okay. Now remember, these are not for eating. There are 4 starbursts in each bag cut up into 4 pieces. You're going to remove them and put them in your hand. And you're going to use your hand to squish them together to make your, what kind of rock? Sedimentary. So let's start doing that. I now have a sedimentary rock. Okay, let's review this. A naturally occurring inorganic. What, who can tell Miss Debbie what inorganic means? Somebody raise your hand. Yes. Yes. It was never alive. Okay? Inorganic. Crystalline solid. Who can tell Miss Debbie what crystalline means? What does it mean for it to be a crystal? Yes, Noah, good and loud.
It means it cools in a specific pattern.
Beautiful. It cools in a specific pattern. And there are over 4,000, now this is incorrect, there are over 5,000 different types, and each have a specific crystal structure. Now you go outside and you look at the ground and you think that's just ground. But under that ground is a wealth of materials that we use every day for our TVs, our cell phones. We use all of these minerals that are in the earth every day for everything. But today, we are going to be talking about gemstones. That's number 2. Gemstones are mineral crystals that have been cut and polished and used for jewelry and other adornments. So how many of you might be wearing a gemstone right now? Raise your hand if you're wearing a gemstone. Okay, a few of you, yeah? Well, you think, well, you wear a gemstone, right? Well, this is a gemstone. We were in a market in this little town, and this is jade. And so this is a gemstone because this is jade that has been cut into a beautiful sculpture. And we went to this little town, and I don't even remember what the price was on this, but I literally only had 50 American dollars in my purse. And I really wasn't lying. Usually you do kind of negotiate. So when you go in, you say, they don't speak English, so they have a calculator, and they put the price in, and you say, no, no, no. And then you put the price in, you're willing to pay really low. And they go, no, 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 because everybody knows the word no. And then they put in the price and you say, no, no, no. And then this goes on for like 10 minutes. And then you say, oh, no, 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 and you leave. And then they follow you. okay, and you get your lowest price. That's how it works. Well, that day I really wasn't negotiating with her. I only had $50 American. So I told her that. And I know this was worth much, much more. This is a giant piece of jade that has been cut into this beautiful piece. And I was like, that's all I have. And she says, no. And I said, oh, okay, that's all I have. So we left, we were going back to get on our boat. She ran all the way to the boat with this piece of jade. And she wanted it for the 50 American dollars. And so my husband was very mortified that I did that. He said, you ripped that lady off. You shouldn't have done that. I said, but that might have been her only sale that day, you know. And we were there about 6 months before COVID hit. So, you know, it was good that we were there helping those people. So anyway, this is a gemstone. So gemstones come in either precious or semi-precious. And whether they're precious depends on their beauty, their rarity, and their durability. And so, for instance, my diamond is a 1-carat diamond, but there's a flaw in it. There are no diamonds unless they're in a museum that don't have flaws. They all have flaws. And we're going to talk about that because they're in stone and they got to crush them and they got to hit them a certain way. And there's people that are diamond smiths. That's their job, to cut these diamonds. And it's very, very tedious work. They have to apprentice for many years to learn how to do it. So it depends on their beauty, their rarity, and their durability. So fluorite is very beautiful, but it scratches very easily. And agate and quartz and amethyst are semi-precious stones. But your most precious are your diamonds, your rubies, and your emeralds. They're the most rare. So diamonds are made of carbon. One of the most common elements out of which most organic material is made, even humans. Who remembers what number on the periodic table is carbon? Yes, 6. And humans in the Bible are known as number 6. Of course, the devil's 666, biggie. He doesn't get my attention. But anyway, we're at 6. God is 7. 7 is the perfect number. That's why 70 times 7 has beautiful significance, because that is a perfect number. But carbon. So carbon is, would carbon mean that diamonds are made out of, it seems like it would be inorganic or organic, but it is, they're inorganic, crystals are inorganic, so I don't know. They form deep in the earth from heat and pressure. Diamonds are igneous and are found in a rock called kimberlite. This is a picture of kimberlite, and you can kind of see the little diamond encased in there. There's probably a little one there. Diamonds are very rare. Diamond mines usually have 1 part diamond to 40 million parts of other rock. So for this little diamond, there's 40 million parts of rock that have to be removed for that 1 diamond. A diamond of high quality to be an engagement ring is the produce and removal of processing of 200 to 400 million times its volume in rock. So my diamond, you multiply that size, that little size, times 400 to 200 million amount of rock had to be moved equal to the 1 of that. So it shows you how rare they are. Diamonds and other gemstones are measured in carats. Now sometimes you'll see with a K, carat with a K is usually representative of gold measurement. But diamonds are measured in carats, which is a unit of weight for precious stones and pearls, now equivalent. Right now it's equivalent to 200 milligrams. It just depends on the time. Diamonds diamond is the hardest of all gemstones, measuring 10 on the Mohs scale of hardness. It is said to be the strongest, most durable, naturally occurring material on Earth. Now, there are other materials that are stronger that are man-made with chemicals. However, diamonds are the strongest natural made thing on Earth. And notice that it comes through heat and pressure. I love the spiritual significance of that. That through heat and pressure, it makes you strong. It makes you, when you go through hard times, it's gonna make you stronger in the end, especially if you put your feet on the rock of Jesus Christ. You will come through it stronger than you were before. So don't be surprised by hard times when they come, because God allows them to come so that you will grow more like Jesus. Beautiful diamond. All right? Diamonds are harvested by crushing the rock finely so that the diamonds can be completely separated. The final stages of separation of the crushed rock with the diamonds are spread out on tables coated with grease. The diamonds stick and the other rocks wash away. Only 20% of diamonds found are jewelry quality. The other 80% are used for drill blades, saw blades, cutting tools, medical and dental tools, lasers, vacuum chambers, x-ray machines, and audio equipment. So that's why some of those things are so expensive. Your cell phone, I don't think there's diamonds, there might be diamonds in the cell phone, but there is definitely gold in your cell phone. But some of this equipment is so expensive because it uses precious minerals to make it. So, all right, the most famous diamond is the Hope diamond. There are other diamonds that are equally as famous, but I love the Hope diamond. It's blue to boron trapped in the diamond's crystal structure. It is 45.52 carats. So that is a big, big diamond. I give you guys, turn to Exhibit A, the next page. I give you guys a picture of the Hope diamond. This is a Hope diamond, and you can go see it. It's in the Smithsonian in Washington, D.C. So I hope that you'll make a trip there, because my favorite Smithsonian museum is the Museum of Natural History, because they have an entire segment that is devoted to gemstones. And it is absolutely amazing to walk through that. You just cannot believe what you're looking at. Now, this is interesting, the top 10 most expensive gemstones in the world. Notice that the blue diamond is the highest, 3.93 million per carat. So if anybody has a calculator, you can figure out how much this is worth by multiplying 3.93 times 45.52, and you'll have its value, okay? Very, very valuable. Birthstones tie their origin into what is called the breastplate, Aaron's breastplate. So in the tabernacle, how many of you did the tabernacle unit with Miss Debbie? Quite a few of you. How many of you were with me last year? Because we covered this a little bit last year when we did Israel in the wilderness. Okay. So Aaron wore this. It was a breastplate right here. And it had 12 jewels that represented the 12 tribes of Israel. And each one of these jewels was given some significance. So if you turn the page real quick, you'll see that each one of these jewels is named. Here's the Bible verse where it's found. Here's the color. It's a ruby. And it is based on Reuben. He was the firstborn child to Abraham. And his wife was Leah. And it was behold the son. So, that's kind of the behold this child we're so excited about. And each one of them has meaning. I think my favorite would be Judah. can't read it. Can you guys read it? What does it mean? Somebody read it for me. I can't read it, it's too blurry. Yeah.
Celebrated and praised.
Celebrated and praised. Beautiful. And what tribe? Jesus came through the tribe of Judah. I love it. And I just think it's beautiful that he is celebrated and praised to this day. And so it's the emerald, and very valuable. And Judah was born to Leah, and Jesus was in that lineage of Judah. Okay? So these would be the jewels that would be on his breastplate when he went into the Holy of Holies. He wore these garments at a very special time to go once a year on the Day of Atonement into the Holy of Holies. Now the cool thing, and this, sorry that I realized Jerusalem is very spelled wrong, but I like this picture, that's why I did it. In Revelation 21, it refers to the 12 apostles, and they each are assigned a jewel, and the foundation of the New Jerusalem is those beautiful jewels. So I think heaven's going to be very, very colorful, very beautiful, very colorful. All right, so back to the birthstones. I think it's interesting that stones have been given some meaning, just like they did here. The meaning had to do with the son of Abraham, and some meaning about that child. But I think it's interesting, for instance, that the pearl is known for purity, and the diamond is known for, fidelity and strength. And so there are meanings given to the stones. However, you need to know that there is no biblical or scientific proof that any of these stones have any mystical powers. Because you'll go online and it'll say that online, that the emerald gives you good luck or whatever. That all has its origins in Eastern mysticism and is absolutely not biblical. Stones are stones. They have tested them. There is no power that comes off of these stones. There might be symbolic meaning, for instance, love or purity, but there is no magical power to a stone. So if anybody ever gives you the stone and says, oh, this is going to give you long life, it's not. It's a stone, okay? It's a stone. I want to warn you about that because Ms. Ruth Ann and I found that even some Christians are buying into that. And that is not biblical and it is not scientific. Okay, so now you'll see on this form that there's a box here. You're going to draw out of a sock a gemstone, not a gemstone, but a mineral, okay? And that will, eventually you'll take that here. After you put it through all these tests, except for cleavage, we're not going to do that because we don't want to break them. But we'll talk about ways in which we test them. Are we ready? Number 3 on your vocab is the streak test. A tool used by geologists to determine the identity of a mineral by scraping the mineral against unglazed porcelain to see the mineral in powder form. Because color is not the very best way to determine what your mineral is, although, to be honest with you, today is probably going to come down to the color, because you're probably going to end up taking a look at one of these sheets and matching it up to this. Or we'll get my phone from Thomas and we'll run it through the app if we can. So we'll have a break when we do that. All right, and we're going to watch a video that explains how to do these tests. But one thing the video doesn't cover is the light that goes through it. So you're going to have a flashlight and you're going to shine the flashlight through the mineral to see if it's one of these things. Transparent, light passes through, translucent, sunlight pass this through. So you will use the flashlight. Each table will get one of these boxes, one of these little plastic boxes. And inside of here is the flashlight that you will use to shine it through your mineral to determine if it is transparent, translucent, or opaque. And then we'll write that down. Inside of here is the streak plate. That's the dark streak plate. And then you have a light color streak plate. The video will explain how you scrape it across to see the powder form of the color of your mineral. Okay? Let me carry this over. Now the other thing you're going to look for is it metallic? Does it have a shininess to it that looks like metal? Some of the minerals you pull out will be metallic. And then you're going to look for luster. This describes how the mineral reflects light. So again, you're going to look at it close with your flashlight and determine if it does have metallic. Now, a mineral can have luster, it can be shiny, but it's not metallic. So you'll have to look at your form here. Is it metallic? Is it non-metallic? Is it dull? Is it pearly? Is it waxy? You'll check one of those boxes. Okay. Now we've already talked a little bit about this. It's the Mohs scale. It's a method for determining the hardness of a mineral on a scale from 1 to 10. Now if you turn to page 2 of your mineral identification, I gave you the Mohs scale. And you're going to, in your thing, you're going to have a piece of mirror or a piece of glass that you can scrape it on to see if it will make a streak in it. And if it does, then it is stronger than glass, which is 5.5. You can do a copper penny. You can scrape it with a copper penny, and if it scrapes, if you can get a mark in it with a copper penny, it is stronger than 3.5. So that's some ways that you can test. And I give you a piece of black construction that you'll put, if you have a piece of glass, you'll put that on there to help you see it better. And the video will go over it as well. And then finally is cleavage. The property of a mineral that allows it to break smoothly. We are not going to break our minerals. Okay, this is where you take a hammer to it and pound on it, and it will break in the same type of shape as its original. What we're going to do, because we don't want to break these, they're beautiful. Some of these minerals are just beautiful. And I want you to go home with them. I don't want you to have them all smashed. So, what we're going to look for is signs of cleavage, like hard, sharp edges. Some of these minerals are very crystal looking, and they have very sharp, defined edges, okay? Water that is drinkable, just call it out. Everybody, potable. Good. So when you get home with a British accent, when you turn on your faucet, you can say, "Mother, isn't it marvelous that we have potable water?" She's going to go, "Oh, you're so smart." Okay, next. The measure of the volume of spaces in a material. You can tell Miss Debbie, yes. Porosity. Porosity is correct. I have these rocks here that are limestone, and they are very porous. There's a lot of porosity. Oh, I almost broke my chain. Okay, so the name of the largest aquifer in Florida. Yes, Mom.
Florida.
Florida. Proud of you. Getting on. Bedrock under Florida, composed of calcium carbonate. Now I added that because that's what you need to know. Yes. limestone. If you have swam in my pool, you swam in limestone. The whole area is limestone. Okay? All right. The replenishment of groundwater by the infiltration of surface water. Yes.
Recharge.
Recharge. Who can tell Miss Debbie what our biggest form of recharge is in Florida? This is not in the video. Anybody? Yeah, what do you think? Yeah.
Like rainwater?
Yeah, what would be the biggest form of recharge in Florida, other than just rainwater? What would bring a lot of rain? Yes. Hurricanes. Hurricanes. Hurricanes are very damaging, but at the end of the day, they replenish, they recharge our aquifers. It's amazing, okay? Next, the movement of saline water into freshwater aquifers. Yes, Sydney. Saltwater intrusion. Okay, very good, very good. All right, now we're moving on to caves, okay? Now, I love this word, the study of caves. Does anybody have an idea? Of course, you have it right there in your thing. Never mind. Speleology. Speleology. So here's another thing you can do with your mother when you come. Mother, I have decided what I want to do with my life. What, darling? I want to be a speleologist. And she'll be like, whoa, what is that? Okay? Impress your mom. Yeah, hear that? Okay. He might go, a spele what? So speleon. Speleon means cave in Greek. So that's where, and the ology is the study of. So it's the study of caves. Now, how do caves form? First, let's get the definition of a cave. A natural cavity beneath the Earth's surface. That, if anybody gets that wrong in 2 weeks, we need to get like a wet noodle that we waffle with. Mr. J, can you use a wet noodle to waffle with if they get that one wrong? So how do they form? Okay, so how they form is there is a weak acid, and it's called carbonic acid. Let's write that down. Carbonic acid. And it is formed by rain or other water in contact with carbon dioxide in the atmosphere or in soils and vegetation. So what happens, we learned about this 2 weeks ago when we talked about fossil fuels. It all has to do with organic material breaking down. When organic material breaks down, carbon dioxide is released, and it creates a certain amount of acidity in the water. It dissolves in the water. So it's animal and plant material breaking down, and some of it is in the rain, and it gets into the porous ground, and it gets to the rock in there, the limestone, and it starts to break it down. We're going to make a cave. Each table will make one. I want different people doing different jobs. So let me show you what you will have at your table. You'll have a piece of tin foil. You'll have some paper towels. And like one of those bottles, but you know. You will have a piece of clay. You will have 2 toothpicks. And you will have sugar cubes. Do not eat them. Okay? And you will get a water bottle, which you will not spray each other with. You're going to turn this sideways. You're going to build your cave sideways. Okay? So one person is going to be putting in the sugar cubes sideways like this. And you want to make sure they're touching. You can stack them a little bit if you want. They've got to all be touching. And they're going to build them in there. Okay? While that person's building that, the other person is going to take out the clay and And do not do it on the tables because it will mess up the tables. You will take it on here and flatten it out. I want you to push and push and push until this is flattened out. And believe me, I tested it and it flattens out, okay? Then the other person who doesn't have anything to do will be sitting there waiting to use these, okay? So what will happen, once you have this flattened out, is you're gonna lay it over your sugar cubes. In fact, you might wanna just put the sugar cubes flat, however you wanna do it. You're gonna lay it, the clay, over the sugar cubes and press it down so it creates ground. So let me see if you guys can think. What do you think these might represent, these sugar cubes? Yes.
Sand.
No, not sand. Yes.
Calcite.
The calcite or the limestone, because limestone is the calcium carbonate, which is a form of calcite, okay? So that represents the rock that is being broken down. What does the clay pressed down over it represent? Yes. No, something that goes over the rock. What might be over rock? Yes. Dirt, okay? Or I guess it could be other porous rock, okay? Or sediment, okay? So it's over it. But remember, our rock and our ground has porosity, okay? It's permeable. Things get through it, okay? So that's where the person that's been sitting there waiting is to use these. So what you're gonna do is you're gonna turn it this way now. It's gonna stay put. You're gonna get to see your sugar cubes lined up with the clay stuck, because you're gonna stick it on the side so you'll be able to see it. And you're gonna take these holes and make your rock or your ground permeable. Take these holes. Take these toothpicks and make holes, okay? I can't talk, it's been too long. So you're gonna make holes in the clay. Then you're gonna take turns. This is why you have paper towels, because it's gonna get wet. That's why you put everything wet. And we do not spray. Thank you. So this is where you're gonna take your little water bottle and you're gonna start spraying it in over your ground, okay? Observing what happens to the limestone rock in here. Does everybody understand what to do? Yes, ma'am. All right, now, the major material that you find in caves and stalagmites and stalactites is calcite. Did anybody have that mineral today? Calcite. Did anybody have it? You did. A couple of you did. Good. Good. So calcite is the most, when you see a stalagmite or a stalactite, and a lot of the beautiful things that are in caves, in fact, you guys have a picture. Get your hand out. Get your hand out right now. I want everybody to look at it. It's amazing. It is Exhibit E. This is terrible. You can't see it. You gotta look. I took the time to color copy these for you. So let's take a look at them, okay? We have these beautiful formations, and they do not take millions and jillions and quadrillions, billions years to, these can happen quickly, okay? So, you have your stalactites, which come down from the top, your stalagmites, which go from the bottom up. So the dripping, some of it stays in the column and some of it goes down on the ground. And then sometimes they meet in the middle and they form a column, okay? So this is the stalactite and a stalagmite joined together to make a column. Then you have a whole bunch of columns that get together and they make a drapery. And then you have all these little teeny ones that are called straws. I love it, they're beautiful. If we have time for this video, which I hope we do, you'll see these little straws. They don't call them straws, they call them something else, but they come off of the stalagmites and the stalactites. And then you have flowstone down here, which is kind of where it all gathers together at the bottom of the cave. Number 22 is a stalactite. C comes first in the alphabet. I'll just put it A-L-P-H. So the stalactite is the first that forms, coming down from the ceiling, okay? The stalagmite forms upwards, okay? So a type of rock formation that rises from the floor. It rises from the floor of the cave due to the accumulation of material deposited on the floor from ceiling drippings, formed from calcium carbonate, lava, mud, peat, pitch, or sand. And you're going to take the sand and you're going to kind of get the water out of it, and you're going to start dripping little pieces, kind of moving your hand like this, and eventually you'll start getting some stalagmites, okay, because they'll start forming. You go right over the same spot and just drip it. It's starting to grow a little bit, and see who can get a stalagmite going, okay? Does everybody kind of understand?